L'Hopital's rule. L'Hopital's rule allows us to use derivatives to calculate the limits of fractions whose numerator and denominator both approach zero or both approach infinity when direct substitution is applied. For a given limit value a, if both the numerator and the denominator evaluated at a are equal to 0, then L'Hopital's rule states that the limit as x approaches a of the quotient f of x divided by g of x is equal to the limit as x approaches a of the derivative of f of x, f prime, divided by the derivative of g of x, g prime. L'Hopital's rule allows us to take derivatives of the numerator and the denominator if direct substitution leads to either 0 or infinity on both the top and bottom, and then we would reapply direct substitution once we've taken derivatives. We'll look at some examples. In example 1, we're asked to evaluate the limit as x approaches 1 of x cubed minus 1 divided by 4x cubed minus x minus 3. Direct substitution would lead to what's called an indeterminate form. I would get 0 in the numerator and 0 in the denominator. Therefore, we can apply L'Hopital's rule. L'Hopital's rule says to evaluate the limit, we can take the derivative of the top and the derivative of the bottom. The derivative of x cubed minus 1 is 3x squared, and the derivative of 4x cubed minus x minus 3 is 12x squared minus 1. Once I've taken the derivatives, I now look at the limit as x approaches 1 of 3x squared divided by 12x squared minus 1. Now if I apply direct substitution again, I get 3 divided by 11. Therefore, the limit as x approaches 1 of x cubed minus 1 divided by 4x cubed minus x minus 3 is equal to 3 divided by 11. Example 2, I'm asked to evaluate the limit as x approaches 0 of the sine of 5x divided by x. Again, direct substitution would lead to the indeterminate form 0 divided by 0, so I can apply L'Hopital's rule. L'Hopital's rule says that the limit as x approaches 0 of sine of 5x divided by x is the same as the limit as x approaches 0 of the derivative of sine of 5x divided by the derivative of x. The derivative of sine of 5x is 5 cosine of x, and the derivative of x is 1. So now I'll look at the limit as x approaches 0 of 5 cosine of 5x. I'll apply direct substitution again and find that that limit value is equal to 5. Therefore, the limit as x approaches 0 of sine of 5x divided by x is 5. This time I'm asked to find the limit as x approaches infinity of e to the 3x divided by 3x. This time, direct substitution would lead to the indeterminate form infinity divided by infinity. As x gets larger and larger, so does the numerator and the denominator, but I can still use L'Hopital's rule for this indeterminate form. L'Hopital's rule says to evaluate the limit, I can do so by looking at the derivative of the top and the bottom. The derivative of e to the 3x is 3 e to the 3x, and the derivative of 3x is 3. Now I look to evaluate the limit as x approaches infinity of e to the 3x. Well, as x gets larger and larger, so does e to the 3x. Therefore, the limit as x approaches infinity of e to the 3x divided by 3x is infinity. One final example, I'm asked to evaluate the limit as x approaches infinity of 5x squared minus 3x divided by 7x squared plus 1. Direct substitution would lead to the indeterminate form infinity over infinity, so I can apply L'Hopital's rule. L'Hopital's rule says to take the derivative of the numerator and the denominator. The derivative of 5x squared minus 3x is 10x minus 3, and the derivative of 7x squared plus 1 is 14x. So now I'm looking at the limit as x approaches infinity of 10x minus 3 divided by 14x. Well, if I apply direct substitution again, I still get the indeterminate form infinity divided by infinity. The numerator gets large and so does the denominator. So I'll apply L'Hopital's rule a second time. In doing so, I again take the derivative of the numerator. The derivative of 10x minus 3 is 10, and the derivative of the denominator. The derivative of 14x is 14. So now I'm looking at the limit as x approaches infinity of 10 over 14, which is equal to 10 over 14, or in simplest form, 5 divided by 7. We've looked at instances for which L'Hopital's rule has been applied to indeterminate forms 0 over 0 and infinity over infinity. There are other indeterminate forms such as 0 times infinity, infinity plus infinity, or infinity minus infinity, and 1 raised to infinity. When these forms arise, you can often use algebra to convert them to a 0 over 0 or an infinity over infinity form, and then apply L'Hopital's rule.